Welcome to the can-it method, estimating volumes of solids of revolution by conceptual calculus. A solid of revolution is formed when a region is revolved about an axis. Consider the region between the curve y equals f of x and the x-axis from x equals a to x equals b. We revolve this region about the x-axis to generate a solid. In Calculus 2, we use integration to find the volumes of solids of revolution. Although integration can give us the exact value, it is complicated enough that students often make mistakes and get incorrect results. Starting with an estimate gives you a way to check your calculations. If your calculated result does not agree with your estimate, then you know to look for an error. One very simple method of estimating the volume of a solid of revolution is to imagine that the solid of revolution is a product you are manufacturing. You need to package the product to ship it to your customers. Since the solid of revolution is always round, you put it in a round package, such as a can or a mailing tube. The can is a simple right circular cylinder, so its volume is easy to find. The product that fits inside the package must have a volume that is less than the volume of the package, so the volume of the can gives an upper bound for the volume of the object. Here is an example. Consider the region between the curve of y equals the square root of x and the x-axis from x equals 0 to x equals 4. Revolve that about the x-axis to form a solid. Notice that the radius is different at different places along the length, but at its widest, which is the right end, the solid has a radius of y equals the square root of 4, which is 2. The solid is 4 units long. We want to put that solid into a tube. The tube should be just big enough around to fit the widest part of the solid, and just long enough to accommodate the length of the solid. This means the tube must have a radius of 2 and a length of 4. The tube, which is a right circular cylinder, has a volume that is the area of the base multiplied by the length. So it is pi r squared multiplied by L. In this example, that is pi times 2 squared times 4, which is 16 pi, or about 50. This is the volume of the tube. The solid of revolution fits inside the tube, so its volume must be less than 16 pi. Thank you for watching the can-it method, estimating volumes of solids of revolution by conceptual calculus.